Hello everyone. So today we are going to learn some very important topic and that is logic gates, right? So what is logic gate? We often think that what is logic gates, right? So a logic gate is basically a building block for digital circuit and that generally have two inputs and one output, right? And we have seven types of logic gates. Now starting with AND gate, we can see here, let me take the pencil first. Yeah. So we can see here, first one is AND gate. So in AND gate, we can see that we have two inputs, that is A and B, and we have one output, that is A dot B. So what is A dot B? You can see the truth table for this, right? This is the truth table for the AND gate. Here we have two inputs. When we have 0 and 0 as input, we can have output as 0. Why? Because when we multiply 0 with 0, we will get 0 only. And when we multiply 0 with 1, we will get 0. And when we multiply 1 with 0, we'll get 0 only. And when we multiply 1 with 1, we get output as 1 only. Why? Because in output we get the output as A dot B. So this is the output for AND gate, right? Now coming with OR gate. Here in OR gate we can have two inputs, similarly with AND gate also, A and B, and we could have output as A plus B. You can see here this is as A plus B as output. Now, seeing the truth table, you can see that here we have 0 and 0 as out as input, then you got output as 0. Now, when we add 0 plus 1, we get output as 1 only. And now, with adding 1 as input, 1 plus 0 you get 1. Now you think that why we are getting 1 on adding 1 plus 1 we are getting output as 1. Now here the thing is that we are having with us binary numbers, right? So in this case, when we add with OR gate, you when we have two both the inputs as 1 and 1, so you get the output as 1 only. And you can see that the output for OR gate is A plus B. So the only exception is that when we have 1 and 1 as input, you will get the output as 1 only. Now coming to the NOT gate, this is just the complement for the input, right? So when you give 0 as input, you get the output as 1 only, and when you give input as 1, you get the output as 0, right? So this is just the complement. You need to just complement the input. Now coming to the NAND gate, this is just the complement for the AND gate. This is the AND gate, right? Um, this is the AND gate, and this is the complement for the NAND gate, right? So this is the this NAND gate is the complement for the AND gate. So now in NAND gate, what happened actually is that when you give the input, just see the output that we are complementing the AND gate A dot B, and then we have the bar, right? So when we have the input at 0 and 0, the output you are getting what? 1. Why? Because when we multiply 0 and 0, we get 0, right? When we complement it, we get it as output 1. Now you can see that 0 and 1 is there in second one. So here also what we are doing, that we are multiplying it and we obviously get 0 as in output, and then we complement it, then we get 1 as output. Now 1 and 0 when we multiply similarly, then we get 0 and then we get output as 1. Now with 1 and 1, when we multiply it, we get 1 as output, and after complementing it, we get 0. So this is basically the NAND gate. Now coming to the NOR gate, what actually NOR gate is? So this is also the complementing of OR gate. You can see here, this is the output, right? A plus B, and then we complement it. Now in inputs, you could see that when we are having 0 and 0 as input, what happened in OR gate? We are having with us 0. Now complementing it, we get 1. Now 0 and 1, after adding it, we get 1, right? And after complementing it, we get 0. Coming to the third one, when 1 and 0 are with us, we are adding it and we get 1. And after complementing it, we get 0. Now 1 in 1, we I had told you in OR only that when we add this exceptional 1, 1 and 1, so we get 1 only, and after complementing it, we get the 0, right? Now coming to the XOR gate. Now XOR gate is the gate in which the output is exceptional, right? Why it's exceptional? Because when you have one as one of the input, you will get the output as one, right? So the basic necessity for the XOR gate for getting output as one is that from one of the inputs, you should have one as the input, so you will get the output as one. You can see the truth table, right? Here we have 0 and 0, no one is there, right? So you get output as 0. Now in inputs, you the second one, you could see that we have one as input. At least I'm not telling it as at least, you should have only one input as the one. You should only have one as the input. Only one is necessary for input, and you would have the output as one. Now you can see the third one, we have only one input and 0 and as another input, and you are seeing that we are getting it as 1 as output, right? Now here the last one is that we have two 1, and the output is 0. Why? Because we should have only one, right? So this is the actually XOR gate output. Now coming to the XNOR gate. What is XNOR gate? So this in this one, you should have both the input as same, right? You can see the first one, now 0 and 0, and the fourth one you could see that 1 and 1. You will definitely get the output as one only. And where you can see in second and third one, where you have one as input in first, one as input, right? We are having in second and third, you could see that we just have one as input. Only one is there, and so as the output is 0. So these are the basic 7 logic gates, which I think that you will learn very nicely. And if you like my video, this is the first video I'm uploading, so if you like my video, just give a hit a like, and please subscribe my channel. Thank you for watching.